Project code ITPW46. Project title: A multifunctional solar PV and grid-based onboard converter for e-vehicle. In For the e-vehicle application, which having only the one mode, source to battery, or so for the solar e-vehicle, panel to battery. So the two different possible ways which is used in a e-vehicle application. But in a proposed concept, different type of modes which is implemented in our proposed e-vehicle application concept. In existing concept, already said that the only panel for the solar panel, solar e-vehicle, the panel to battery in a e-vehicle. In between, we have to use the boost boost converter, diode bridge rectifier. For using the solar e-vehicle, DBR is not used. Only the boost converter is used, and the other isolated converter like flyback or push pull converter is used to low grade the voltage and given to the battery. It is a conventional one. Conventional having the drawback of slow behavior and which is not reliable, and a grid connected application is not possible. But in a proposed concept, we have to use the different modes. Like the first mode is PIC, that is plug-in charging mode. In a plug-in charging, grid connected to diode bridge rectifier, in between converter and boost converter given to the battery, which is normal PIC mode. Second mode is PV mode, that is PV to boost converter to battery. Third one is propulsion mode. In a propulsion mode, the PV is not working and the grid is not working. In this case, the battery itself acts as a source and which is given to the load at boost. In between the boost operation is happened. The fourth mode is the same grid and PV is not working, but the battery is given to the load by the buck operation. These are the four modes which is used in our proposed converter. This converter is non-isolated converter. Proposed advantage is high reliable and because we have to use the both the non-isolated and isolated converter in a single concept. So for using the isolation which is used to give the safety to our proposed concept from the fault, so the isolated concept is used, but isolated concept having the more number of components, so in non-isolated having the less components and compact, so both isolated and non-isolated converter combined in our concept to get the high reliable system. So proposed converter, the solar panel given to battery between converter and grid to battery and battery to load. Application mainly used for e-vehicle application and grid connected application and renewable energy application. The system is implemented in MATLAB 2015b version. Microprocessor MT lab is a microprocessor lab which is giving the program to the PIC microcontroller to generating the pulses in our proposed prototype. Minimum hardware requirement is power MOSFET transformer to excite the PIC microcontroller and solar PV like 12 volt 10 watts panel and other active and passive components used. Thank you.